This question, we have a function right there, and we're supposed to take the derivative of it. So let me bring that function down here and do a fraction bar, and we have 5x squared tangent x over secant x. Now, you could take this derivative and right away go, oh, it's a fraction. I'm going to have to do the quotient rule. But instead, first simplify whenever. So when you have, this is a good lesson for trig functions. When you have tangent, remember that's sine over cosine. Wait here, let me write them up here. We have sine, cosine, tangent, which is sine over cosine. We have cotan, which is the upside down of that. And then we have secant, which is 1 over cosine, and cosecant, which is 1 over sine. I'm scribbling those in there. There we go. So these are like the flips. You know, you flip it, you flip it, you flip it, right? Sine, cosecant's the upside down, cosine, secant's the upside down, tangent, which is sine over cosine, cotan's upside down. So as soon as you see tangent, you need to think, oh, here, let me keep the colors the same. That's tangent. That's sine on the top, cosine on the bottom. Now you might think, well, Mr. Ernst, shouldn't we put sine over cosine right there? It's the same thing. Whether you put the cosine right there or you put it on the bottom, it's all the same. It's going to be way easier to put it on the bottom like this. I can prove it to you with numbers. We probably better well here. Let me prove it real quick. If you wrote sine over cosine right there and said that's not the same as this, yeah, it actually is. Here's how you could prove it. You could just then come in and multiply. If you wrote this first, you could multiply top and bottom of the overall fraction by cosine, and what would happen? These would cancel. Sine would be on the top, cosine would be on the bottom. See, there's my little proof that it's the same to just stick the cosine on the bottom as to stick a sine over cosine all together in the top, and that's awkward looking anyway. So just stick the cosine on the overall bottom. Now, what about the secant? Secant, as it says right here, secant is what? 1 over cosine. So that means this is 1 over cosine right there. So what happens, you see? This is over 1, cancel. So I haven't done a derivative yet, by the way. This is simplifying. This is just simplifying. So now it's 5x squared sine x. So, well, here, let me first simplify. So I simplified first. Second, take the derivative. Just kind of go fast and get scribbling. Take the derivative. Does that make sense? So first clean it up. See how it's nicer now? It's not a fraction anymore. That's going to make your life a lot easier. Now take the derivative once you've cleaned it up. So whenever you see things like tangent or secant, you break them down. Tangent, sine over cosine, secant's 1 over cosine. Nice things happen, and it's not a fraction anymore. So now it's time to take the derivative. All right, so how do we take the derivative? Well, the 5x squared. Now, what's a 5? It just sits there. And you have numbers multiplying an x expression. They're just spectators to the event. They just sit there. Oops. So you know how the 2 comes down, multiplies. That's 10x, subtract 1 from the power, so just x to the 1. And the derivative sign is cosine. That's wrong, but a lot of people do that. Why is that wrong? You need to know that's wrong. What did I just do wrong? I did not do the product rule, right? So in other words, the first part was right. Derivative 5x squared is 10x to the first. That's awesome. But then the sine x just comes out. Remember when you have two functions of x, here, let me circle them. A function of x and a function of x multiplied, we're going to have to do the product rule. Two functions of x multiplied, they take turns. Remember that? You can't just do the first one, do the second one. No, no, no. You do the first one and the second one stays the same. Plus, and then the first one stays the same. 5x squared, right? He stays the same. Well, I don't want to put an arrow there. And then it's the derivative of the second one. So the sine x is now, what's the derivative of sine x? Negative, or I'm sorry, cosine. Derivative of sine is cosine. Yeah, let's just do it right there. Cosine x, right? Don't forget the product rule. You got to take turns. So I did drew to the first one, second one just sat there. Then the first one sat there, drew the second. They take turns. The first one went first, the other one sat there. Then the first one sat there, and the second one went. So there's our derivative. Now, and that's the answer. Oh, they factored out a 5, but it doesn't matter. You could just type it in just like we have it. We have it correct. It's the same thing. Now we got to plug in a 2. Last step, f prime of 2. So just plug in a 2, sine 2 plus 5x squared cosine 2. Hit the buttons on your calculator. Now, here's the one thing to watch out for. You've got to make sure you're in radian mode on the Desmos calculator or whatever calculator you're using. Radian mode for those are not degrees, are they? If they don't have a degree symbol, they're not a degree. You think, how do you know it's radians? There's no pi. It doesn't matter. You don't have to have a pi. If you have a degree symbol, you're a degree. If you don't have a degree symbol, you're not a degree. You're a radian, even if you don't have a pi. So those are radians. You know what? Here's the button on the Desmos calculator. This is a different example previously, but you got to click the radian button, not the degree button, when you put it into the Desmos calculator to get the right answer, and then you'll get this answer right there. And so there we go.